When designing a structure, there are two different diaphragm analyses that can be done: flexible and rigid, for both wind and seismic design. The choice on whether both flexible and rigid, flexible only, or rigid only analyses are conducted is specified in the structure input form. Depending on which analysis is used, the distribution of the load will vary. If a flexible analysis is being performed, the building face between shear lines is modeled as a simply supported beam. The shear lines are seen as pinned supports, so the load striking the building between the supports is distributed via tributary width and goes entirely into these supports. If a cantilever beam is used, these loads go entirely into the adjacent support. In general, a flexible diaphragm is present when the vertical elements are much stiffer than the diaphragm itself. For an irregular structure, this analysis assumes that there is a drag strut or other force collection system bridging any gaps in the shear walls along a given shear line. It is therefore to the engineer to design these force collectors. A rigid analysis accounts for shear forces due to relative stiffness of shear walls and the torsional behavior of the rigid floor diaphragms. The torsional eccentricity is related to the distance between the centroid of the applied design load and the center of rigidity of the shear wall. An accidental eccentricity is added or subtracted from this distance to account for uncertainties. To calculate the eccentricity, the center of loading and the center of resistance must be calculated. The calculation of the center of rigidity of the diaphragm is based on the relative rigidities of the shear walls. Shear walls offer four options to the user to make this estimation, which are found in the design settings. For more information on these options, please look at the video entitled Design Settings for the Canadian version. The recommended method is to estimate the rigidity of each wall as the product of the length times its tabulated shear capacity. You can also enter your own rigidities on a wall-to-wall basis. These rigidities are multiplied by the wall length. You can also assume that the relative rigidities are equal so that the total rigidity is proportional to the wall length. In this case, you are neglecting the relative stiffness of the wall assemblies. For a rigid analysis, the more rigid the member, the more load is allocated to it. The last option in the Settings menu lets you distribute the forces according to deflection. The less the member deflects, the more load will be allocated to it. This is an iterative procedure that is done until the deflection of each segment converges to the same amount. Both flexible and rigid diaphragm analyses are performed if possible. A rigid analysis must have all shear lines loaded in order to work. We will therefore delete all the loads and enter a seismic line load on one shear line and rerun the design. In the log file, you can view the calculation made for the rigid diaphragm analysis. Depending on which option you chose in the design settings to calculate the rigidities of the walls, the units for rigidity will be different. The accidental eccentricity, location of the center of rigidity, and even the torsional rigidity is shown in this file. At times, engineers need to use their judgment. For example, if a rigid analysis yields 5% to one line and 95% to another, while the flexible analysis is found to be 50-50, the engineer should probably design for the larger of the two loads for the individual walls. In reality, for wood structures, the diaphragm is typically found to be between a rigid and flexible diaphragm. Thus, designing for both will cover the whole envelope of possible diaphragm rigidities. Shearwalls has integrated a design option that allows to design the structure, when parameters are left as unknown, based on the worst case rigid versus flexible diaphragms, thus having only one physical design wall for all load cases rather than having different walls for each load case. This option can be found in the Settings menu and is further discussed in Tutorial 3, Design Settings. This concludes the tutorial about flexible and rigid diaphragm distribution.